Okay, let's start the lesson. So this first topic of the year in grade 11 maths is exponents and surds. And in the previous lesson, we basically just spent some time going over the laws. So law number 1, which is basically the additive law, bases are the same, you add the powers. Law number 2, if the bases are the same, you can, and you're dividing, you subtract the powers. And then law number 3, basically, if you've got powers, you've got a base, a power, and there's a power outside that, you simply multiply the powers together. And you can do this sort of going forwards or going backwards, but essentially all you're doing is that power is being multiplied by the power inside. If there's no power there, it means that there's a power of 1.
Sorry, Mr. S, please unmute.
Myself. There we go. No problem. Okay, so that is law number 3. I just want to get, oh, and then we also have 2 definitions. The one is that anything to the power of 0 is 1. So you can see the example down here, like if you have x to the 4 plus 4 in a bracket, and it's raised to the power of 0, doesn't matter, it's 1. And if you have 3 to the power of 0, that's also going to give you 1. And then we touched on this last bit in the last lesson. If you've got something to the negative power, so if you want to change something from a negative power to a positive power, you simply take it from the top of the fraction to the bottom, or from the numerator to the denominator, or the opposite way around, and it changes. And so an example here would be like x to the minus 2 is on top here, and then when it's below the line, it's a positive x to the 2. So those are the basic facts that you need to know. I just want to if you feel like you are confident in those things that are on the screen right now, just give me a thumbs up so that I know roughly to the arc of our journey today. If you feel a bit unsure about those facts on the board, give me a thumbs down. Because we're going to build on top of this for the rest of today, but it is important that it's kind of there with everyone. Okay, cool. Well, then let's get going. Just a little warm-up question to stretch the brains. What is the answer to that question? 2 to the power of 4 times 2 to the power of 6. 2 to the power of 2. Think about what laws do we need to deal with. And then we really appreciate everybody putting their answers in the chat, because it's almost like our class discussion space. And even whether you're wrong or right, the information just helps us get a sense of what's going on with your thinking. So the way I would see this question is the top line, the bases are the same. So I add the powers. So that would be step 1. And then step 2 would be the bases are the same, subtract the powers. And so your correct answer should be C. All right. So the first one is C. If you have a question, just put it in the chat, but I'm assuming for the most part, we're okay there. What about this one? What is 3 to the power of minus 1 equal to? And then you have 4 different choices there. Okay. So this is just using that definition that I spoke about earlier, that you can rewrite this as 1 over 3 to the 1, which is 1 over 3. You can see that the negative power has now become positive because it's gone from the numerator to the denominator. And so the correct answer would be C. Cool.
Great going, guys.
Awesome. Let's just do one more with the negative powers, then I will take it up a notch. 4 to the power of minus 2 is the same as what? Okay, I can see that you do understand the exponent laws well. So step 1, 1 over 4 squared. Basically, that's how I get the positive. And then that converts to 1 over 16, which is A. Cool. So we're comfortable going from negative powers to positive powers. No problem there. Let's have a look at something like this. What is 2 to the power of minus 3 divided by 2 to the power of minus 4? You'll notice that the complexity is going up a little bit, but I like what I'm seeing. And I love
a bit more juicy.
Yes, I love to see some debate in the chat. In fact, what I would love is I'd love someone to come on and share their thinking. So it's not about the answer. I want someone to come on and just say, what were they thinking when they answered the question? So you can pop your hand up. And what do you guys, who's willing to share their thinking?
Anybody feeling a little brave today?
Yeah, it's just chop chop. We're not going to have a deep conversation, I promise. It's just a quick thinking about.
And it was super nice.
Okay, into Bocheng, let's go to you. What do you think? What thinking is going through your head?
So we are dividing, so the bases are the same. So we are going to subtract the exponents.
Okay, so talk me through to 2 to the power of minus 3, and then what do I do?
It's 2 to the power negative 3 minus negative 4, and then you get 2 to the power 1.
Aha. Now, there's something special that you spotted, which is this bit. What is this bit in green telling? What did you figure out there?
2 negatives give us a positive, so it's negative 3 plus 4.
Yep. And so that's how you get your 2 to 1. Well done. Another way of doing this is you could have also brought the thing from below the line above the line. And so if you had that, you bring the 2 to the negative 4 up, you get 2 to the power of positive 4. And so now you can use law 1 to just go and you get the same answer. And so that was awesome, awesome, awesome. And the answer is A. Right. Any questions or comments about that? There was a nice debate in the chat. Maybe we should do we have another one? Oh, that's quite straightforward. That's also, okay, let's do this one. What is the answer to this one? 2 to the power of minus 3 to the power of minus 5. So I think a lot of you have realized this is just a straight law 3, right? The two powers are multiplied, and negative times a negative is a positive. And so we get 2 to the power of 15, which is C. Perfect.
Nice work, everyone.
All right, I can see that the warm-up is done. So now what you're going to do is you're going to get some quality time to practice, and I will be available to take questions, but I want you to do these 5 questions by yourself. So you are going to try and get the answers. Once you get them, you can put them in the chat. But what I would like to see is I would like to give you 5 minutes, or maybe like, yeah, about that, to work on this. And then if somebody is uncertain about something, you can ask a question by raising your hand. We can chat audibly, or I'll look at the chat. Okay, off we go.
You've got this, guys.
You can do it. I see Katleko and Fila. I've got some answers coming through. Thanks for that. See if you agree or disagree, but make sure to post your own answer. If you are unsure about something, yeah, I'm happy to have a conversation about one of the questions if there's anything you're unsure of, but for now, practice makes perfect. Yeah, so the first three are pretty definitional, but 4 and 5 start to increase the complexity.
Looking good, guys.
I'll just put these in so you can see the answers. So 4 and 5 are a little bit trickier. Think about what laws do you have to apply. Remember, there's a secret 1 hiding out here. Let's make it. I suppose I should have written 3 to the 3 here. And yeah, you should get 8x to the 6 over 27y to the 9. So that is what I get for 4. And what about 5? What's the answer going to be for 5? The only thing I think will catch people is the -3. Because remember, the -3 is being squared. And what does that mean? It means -3 times -3. So another way of maybe seeing it is like -3 squared y to the 3 squared, which gives you 9 y to the 6. You should have that. All right. Now, I just want to pause for a second and ask, are there any questions or comments? Or if you generally feel like you're understanding this well, could you just give us a thumbs up in the chat? Or if you feel a bit lost, if you feel a bit like, whoa, this is going over my head, just give us a thumbs down in the chat. Again, so we know the general body language of the class, since we don't have physical, representations. All right, well, it looks number 4 again. Okay, so the thing that's happening with number 4 is that all that's happening, let me get a pen that's smaller, is the 3 is being raised to this one, to this one, to this one, and to that one. So that's why you see 1 times 3, 2 times 3, 1 times 3, 3 times 3. So this is just law 3. And then you can imagine 1 times 3 is 3, 2 times 3 is 6, and so on. So that's all that's happening in number 4. Okay. Let's do these 4 questions. So I want you to try and simplify. So the question is to simplify these 4 questions using what you've done so far. And yeah, as you do that, you're free to ask questions, but for the most part, I just want to see how you apply the laws for exponents. And then D is just a little something which we'll talk about. But yeah, now is a great time to ask a question if you do have a question, because I'm free and willing to apply my mind to help you.
Keep going, guys. Pop those answers in the chat as soon as you have them.
Yep. There we go. Oh, I like what I'm seeing. Yep. Jens, Tabojo is, so we get, look, there might be a different question, yeah. 12 times a to the 7 times b to the 6, yes. So A is looking great. That's awesome. What about number for B? Sometimes what I like to do when there's division is I write it more visually. And when I can see it like this, it sometimes helps me a little bit. So don't be afraid to rewrite division in the more visual way, because then it's easy to kind of see this goes with this. This goes with this, and then that goes with that. Kind of makes it nice and clear. So I should get so watch out for that -3. I think some of you will have got caught because a positive divided by a negative is a positive. So for the most part, B seems to be okay. To watch out for the -3. Let's have a look at C. So with C, there's different ways of doing it, but I think let's do it like this initially. You'll notice that the 3 gets applied to each of the items inside the bracket, which gives me -27, A to the 9, B to the 6. Now you may ask yourself, why is -3 cubed negative? Whereas before, when we were squaring things, they were positive, and it lies in the fact that there are 3 things. So if you think about it, negative times a negative, that's positive. But if you times it by another negative, you end up with -27. And so that is where the -27 comes from. Okay. I'd love someone to explain, or come on, just share their thinking. What does it mean when you have this funky looking thing over here? What is this strange looking thing over here? And what does the 4 mean? Because we haven't explicitly talked about it yet. And so I'd love to know if anybody could share their thinking, if they're willing. Like, how did you approach this D?
Anybody who would like to tell us? We'd love to hear from you. We love hearing your voices.
We do. We very much do. So all I'm thinking of it, Inati, there we go. Inati, how did you make sense of this, like this funny bracket and then the 4? What were you, do you know how to translate that, or what did you think?
So that thing is like the 4th root, right?
Yeah.
So like I found the 4th root of 16.
Okay.
Which is 2, which was 2.
Yep.
And then since we multiply the exponent when we are square rooting it or cube rooting it, I divided the a to the power of 16 by the 4, and then got a to the power of 2.
Okay. You got a to the power of
a to the power of 4. A to the power of 4, sir. Perfect.
Okay. So your final answer was 2 times a to the power of 4.
Yes, sir.
Perfect. Okay. Thank you, Inati. That was great. Let me explain what was going on here. So Inati said, look, the 4th root is just the number that basically when you times by itself, 4 times, it gets you 16. And so the one way of doing this question is to say, well, 2 times 2 times 2 times 2 is 16. So that's why this over here is 2. But then you need to ask yourself, well, what variable times itself 4 times will give you 16? And that would be this. And so you get a to the 16. And so that's why this answer over here is a to the 4. But there's another way of doing this. The other way of doing this is to know that the 4th root is equivalent, and we'll talk about this in the next lesson. The 4th root is the same as raising something to the power of a quarter. So if you've seen that before, won't you just give me a thumbs up in the chat? And if you've seen that the fourth root is the same as raising to the power of a quarter. I want to see how many of you have seen that before. Okay. Now we're going to talk more about this in future, about how we convert from root form to exponential form. But basically, the way you would solve this question now is you could say, well, 16 is just 2 to the 4. And you could say that is like that. And now you would just use law 3 to say, well, I multiply by the powers inside. And so what is that? Well, what's 4 times a quarter? And what is 16 times a quarter? Well, we get 2 to the 1 and we get a to the 4, which is good news for me because it's the same answer that we got over there. Now that's coming in a future lesson, but I just wanted to put in a sneak peek so that it's kind of familiar for you. Now, there was a question, can I explain B again after explaining D? So all that happened in B is I'm dividing, and so 12 divided by -4 is -3. X to the 5 divided by x to the 2, I'm subtracting the powers. So 5 minus 2 is 3, and then y, it's 8 minus 4 is the 4. Yeah, Fila, you have a question.
You answered my question, but what I wanted to ask is that I understand how you explained it, but is it okay if I said 2a to the power of 16 divided by 4, and then that's how I got my answer? It's not like necessary for me to write all those steps that you mentioned. Okay, so we'll talk about this more in future lessons, but it's dividing by 4 wouldn't actually work in most situations. It does by coincidence here, but in future situations, straight dividing by 4 wouldn't normally work. It won't give you the right answer. So you don't have to show all the working I showed here, but can we reserve to come back to that, Fila, in a future one, and we can debate? Because I think that I need to know a bit more detail about what you're saying. Okay. Cool. Yes.
Nitsibogeng, what's your question? And then we'd do a nice little stretching break.
Sen, okay,
yeah.
Number like letter A, I understand that you said -3 times -4, which gave you +12, right?
Yes.
And then you also got a to the power 7, b to the power 6. I understand that you added the exponents, but
yeah.
How, like, I don't understand why you added those exponents, because the -3 and -4 the bases, and they're not the same.
Okay, so are you worried about this thing over here, the coefficients? Is that what's
letter A?
Oh, letter A. Oh, in the first one. Okay. So -3 times -4 is 12. But now imagine if you wrote these next to each other. Oh, wait. Oh. So because it's multiplication, I can rewrite this so it's like this. Would you agree with me?
Yes, sir.
So now the bases are the same. What we do is we simply add the powers. So for A, we add that, and for B, we add the powers. Does that make sense?
Yes, sir.
Perfect. Perfect.
Thank you.
Awesome. I'm glad I could help. Everyone, what we're going to do now is we are going to have a little brain break. And the first part of our brain break is to stretch. So turn on your cameras and let us see your wonderful faces, and let's give our bodies a break, because we know we're not designed to be sitting for as long as we sit for generally in life. And so what I want to do is I want to start by us just rolling our shoulders, because that's the first thing that gets tight if you sit in front of a computer. So let's just roll them out. I feel like I'm an aerobics instructor at the Virgin Active, but you know,
here for it.
Yeah, and we need it because our shoulders are tight. So roll those shoulders back.
Loving those cameras going on. Shout out to Debuho, Isa. Come on, guys, don't be shy.
Let's roll them forward. and feel that stress melt away.
Yes, more faces. Shout out to Deboheng, Vila,
Yes,
Zoom user.
part of the maths family, then it's like a family meeting then, and you feel like, okay, I'm on the bus.
Don't have
Okay.
FOMO, guys.
So let's do some tricep stretches. If I can remember what I'm doing, I'm looking at myself in the computer and I'm like really confused. Can I do it? Okay, let's do it. You do it. No, I'm so confused. Tricep stretch 1, and then tricep stretch 2. And then let's do this one.
Shout out to Bongo Gutle, Apelele, Monetopola. I hope I said that right.
Yeah.
Oh, Beverly's webcam is not working.
Okay, and shake it out. There we go. Oh, how much better does that feel? Oh my goodness. Okay.
Feeling refreshed, ready for this last half.
My brain just feels like it's like, thank you for taking the time to stand me up and let the body
We just
unwind.
hit the reset button.
Yeah, it is. And your brain basically goes, oh, now I can download all the learning that you've done in the first half an hour and put it in file, save as.
Yes.
Okay. So let's do this little puzzle question just to kind of break up from what we were doing. Can you tell me what a Christmas tree plus a decoration plus a present is? I'd love to know if you can solve this puzzle. And then if you've got it, why don't you put your hand up and you can tell me how you got it. I'd love to hear the thinking you used.
Whoa, that was quick. We already have our first answer.
Samokela, would you like to share how you got the answer? I think I agree.
Samokela doesn't want to share the secrets.
No. So I definitely agree the first one is 5 and 5, and that 5 is going to be consistent. So it's going to carry through. Does anybody agree with the first answer? Let's have a look. So this must be 7 because 5 times 7 is 35. And then this over here is going to have to be 13. And because it's pluses, the order doesn't matter. So I agree. Zan Desile and Letabo, 25. I agree with you. Buasile, I get 25. So I get 5 from the first bit here. I get 7 here. I get 13 here. And the final line is just add them up. And so we get 25. Okay.
Nice one, everyone.
Cool. Let us return to our questions. And we're going to look at a different type of question now. So in this question, you have to simplify the expression. And you'll notice that there are lots of bits that are around and they're being multiplied. Now, the problem that I spot straight away, and maybe you spot it too, is that the bases are no longer the same. And that presents some problems. Does anybody have an idea as to how we could bring some more of the exponent laws back into play? Vila, what do you think?
So we know that 4 and 8 are multiple, but prime numbers of, I know, but then I can change 4 into 2 over 2, and I can change 8 into 2 over 3. Then now our bases are the same.
Okay, so what you're doing, your technique is to make the bases the same, because if they are the same, it means you can use the laws we've learned about.
Yes.
So, we're going to
say,
great tip. Yeah, go for it. Yeah. No, go for it. Yeah. So what were you going to say?
So we know that there's like a 1 there at the top, but we don't really write it. Then when I say 2, with the 4, when I say 2 to the power of 2n.
Okay. Or let's just go 2 to the power of 2 for the 4. And then what's going to happen for the...
And then when I say 2 to the power of 3.
I'm going to pause you there for a second. Perfect, Fila. You have been super helpful. What I would like now is, given what I've given you so far, I want to see, can you try and get the final simplified answer for this question? So the first step was change the basis so the bases are the same. But what you need to think about is, how do these things interact, right? Like, how do these two entities interact? And then what stuff goes after that? So I want to give you some time and see if you can solve that question. See if you can do it. And then pop your answer in the chat.
Mr. S, I'm not sure if Fila has a question or...
Okay, let's go there.
So it wasn't a question. I thought you were looking for the answer, so I'll just pop in the chat.
No, okay. Yeah.
No,
well,
it's fine.
I appreciate your sharing of your knowledge. It is much appreciated.
Love the enthusiasm.
Yes, I do. Would anybody else like to talk us through the thinking behind this next step? Because I see a couple of different answers coming through in the chat. And so maybe there's something going on when these powers interact. Maybe somebody can help us. Otherwise, who would like to?
Any ideas or tips, guys?
I'll give you one tip. Whole of n plus 2 gets multiplied by the whole of 1. The whole of n plus 1 gets multiplied by the whole of 2. And that's my little tip to you. This whole thing gets multiplied by this whole thing. Okay, so I suspect I know what's going on. If you multiply 1 by n plus 2, you just get n plus 2. But if you multiply 2 to the power of 2, if you multiply this 2, it doesn't just get multiplied by the n, it gets multiplied by the 1 as well. And I suspect that's a lot of students are getting a little bit caught out, because the 2 gets multiplied by both of these things. And so if you know that, the same thing should bottom, on the bottom here, you should go 3n minus 3. So I'll even just, let me put this back here so you can see it. 2 to the 1, 2 to the 3, 2 to the 2. So if you know that that's how they must be, then try and see if you get to the final answer and see what you get. I was thinking this could be 3n plus 4, and this could be
Mr. S?
What's the,
We have
is there a question
from Beverly? Yes, I think there's a question.
Okay, unmute, we can go from there.
Hi,
Go
sir.
ahead, Beverly. Yeah,
Sir, can I try answering the question?
please do. Yes, tell me your thinking from this point.
So I started from where you ended with. Yeah, and then I said 2. Since all the bases are the same, I just said 2 to the power of n plus 2 plus 2n plus 2 minus 3n minus 3.
Okay, so the main thing I want to watch out for is, did you put the thing you're subtracting in a bracket?
Yes.
Okay, you are winning at life, because that's the sneaky bit. Okay, tell me the next step then. What's after that?
And then I said 2 to the power of 3n plus 4 minus 3n minus 3.
Okay, but watch out.
Bracket.
Because what do you get when you go minus minus 3?
Positive.
Yes. So that's what you need to watch out for. So you get positive 3 there. Okay, because you say minus, you're not just minusing the 3n, you're minusing the 3n minus 3. And so that's why you get minus 3n plus 3. Okay, so what's your final answer going to be then?
It's going to be...
So this cancels
2 to
out.
the power of 7.
Yeah, perfect. 2 to the power of 7. And if you wanted to write that as a number, I mean, you could, but 2 to the power of 7 is fine. So that's the one way of doing it. The other way of doing it is to say, look, I've got my 3n plus 4. If I bring the thing on the bottom above the line, the sign has to change. So the stuff from the bottom will become minus 3n plus 3. So notice how when it came to the top line, the 3n became a negative, the minus 3 became a positive. And now you can just apply law 1 and you get basically the 3's cancel out and you get your 2 to the 7. So there's 2 ways to do the same thing, but that's the way I would approach it. Very nice. So let's have a look at another type of example. Just give me a thumbs up if you followed my thinking in that question, because I want to do another proper example like this. If you're feeling very confused, give me a thumbs down, but I just want to get a feel for the group. Okay, cool. Well, then let's have a look at a question here. A little bit, let's see if let's go with this one. Okay, so I want you to try and answer this. Well, maybe we should do it together. No, actually, I'll tell you what, give it a go. I'll give you 2 minutes to start, and then I'll ask somebody from the class to come on and give us a bit of a tip. But basically what we're trying to do in this question is we are trying to simplify the expression. So I'll give you 2 minutes to just try and start. And then after 2 minutes, I'll get some tips from the class. Off we go. So Nakateko, is it 22 times 3? It is times 3. You're quite correct. But one of the problems we have is the bases are not the same. And so what I want you to think about is earlier in the lesson, we said that the prime factors are quite important. And so in the scenario, what prime factors might be helpful? I was thinking 3 times 2 could replace 6. That's my little hint. Oh, Tandalwetu agrees with me. What other hints could some people from the class give us in the chat? And Tandalwetu says 11 and 2 for 22. Yeah, because 11 is a prime number. Now, maybe I even write it as a times. A dot stands for times as well, but just to be careful here. Actually, no, dot is much easier here, so let's just put a dot. And then 3 is already a prime number, and 11 is already a prime number. Yeah. So if that's the case, now I want to simplify. What is the next step going to be? Someone can put it in the chat, or they can raise their hand. What's the next step going to be?
Anybody out there? Deborah.
Yeah, you can unmute there.
Don't you distribute the 2x in the bracket for 3 times 2?
Yep, exactly what you do. You distribute it, and so you get 3 to the 2x times 2 to the 2x, and you get 11 to the 2x.
Yes.
What do you think we're going to get on the bottom?
11 to the power 2x minus 1.
Yep. And what else is going to be there?
Times 2 to the power 2x minus 1.
Perfect. And then this one is easy. All right. So that is good news for us. Thank you so much, because our bases are the same. Now, there are a couple of different ways to do this, but what I think is the easiest is just to take, and again, there's no right, I mean, there's a couple of ways, but what I would suggest is saying, look, just take the whole of what's on the bottom to the top and just change their signs. So what you get is you have 3 to the 2x, and then when I move this one up, it's going to become 3 to the minus 2x. I have 2 to the 2x. When I move the 2 to the 2x minus 1 up, I'm going to get minus 2x plus 1 because I'm changing the signs. And then I've got 11 to the 2x already. And when I move the 11 to the 2x minus 1 up, it's going to become minus 2x plus 1. So notice how all the signs change when I move from the bottom to the top. That's a really helpful tip to speed things up. And then I want the final answer from you guys. What do we get for that, for the final answer? Because I'm thinking this is just going to be 3 to the 0. This is going to be 2 to the 1. And then this is going to be see if you agree with me. So these cancel out and give me 2 to the 1. These cancel out and give me 3 to the 0. And these cancel out and give me that. So what's my final answer going to be? People of the room, what do we think the answer is going to be here? So we know 3 to the power of 0 is the same as 1, right? So it's just a 1. 2 is just itself, 11 is itself, and so the final answer would be 22. Yeah. I like it. I like what I'm seeing in the chat. Beverly, Buyasile, I love it. Now, if we look back on the steps that we took to solve this problem, step 1 was breaking down the bases into prime factors. Step 2 was applying the power law or law 3. And then step 3 was like cleanup. And then there was a 4th step, which was just getting to the answer. So that is the basic process. Now, to finish the lesson today, all I'm going to ask you to do is to attempt question 2 here. So you'll notice this question over here. This is our last question for the day. And I want you to try and fly solo on this one. And then we're going to call it a day for today because you've worked really hard. And I think we need to give your brain some time to press save as and label. All right, off you go.
Last push for the day, guys. Let's make it count.
Hmm. And if there are any questions, also feel free to pop your hand up and we can discuss. Hmm. Okay, so let me zoom out for a second. So I'll explain while everyone is working on this. So in the first question, the key word here is to simplify. And I have this rather complex looking expression over here. So this says 6 to the 2x times 11 to the 2x, 22 to the power of this. And, it's quite messy. And so in order to simplify, it's not as easy as just applying law 1 and law 2 or in law 3. We actually have to do some pre-work. And the pre-work is to split the bases into prime factors. So 3 times 2 is 6. 11 is already a prime. 22 is 11 times 2. And 3 is already a prime. And if I look back on question 2, you can see I'm doing the same step in question 2. I'm breaking down the bases into their prime factors. Now, the third step is to apply law 3, where I take the power and I apply it to each of the powers inside. And so that's what I'm going to do here. And that's what I'm going to, my next step here. Okay, so I hope that helps. We're almost done with this one. So how would my next step look like? So there's just a 1 here, in case you're wondering what's. So this is going to be 2 plus 5. All right, so in this situation, again, there are many different ways to do this, but what I think is the quickest is just to write down, okay, well, I've got an 11 on the top. And clearly I would like for the 11 on the bottom to be next to it. But in order for that to happen, I need to bring the 11 above. And when I do that, I have to make a correction. And so now the n plus 1 on the bottom becomes negative n, negative 1 on the top. And then a very similar thing is going to be happening for the next step. So I get that. And then the last one is 5 to the n plus 5 times 5 to the negative n plus 1. So what's that going to give me? Well, yeah, n plus 1, that's going to be 0. And then over here, the 2 is going to be to the power of 4, because I have minus n minus 1. And then the 5 is going to be to the power of 6. So you have 2 to the power of 4 times 5 to the power of 6. And yeah, that is, I mean, if you put it into, I mean, that would be fine. If it says without a calculator, that's your final step. However, yeah, let's have a look. 2 to the power of 4 will be 8. 5 to the power of 6. Did I do it wrong? Let's have a look at the, where would I have made a mistake? Let's have a quick look.
It would be 16, Mr. S.
Aha, did I make a, let's have a look. So, and then we'll, I'm happy that this is that. And then this is, so this is to the 0. That is to the 4. And
Mr. S, I think they
yes.
mean the sign for the +1, for the 5 to the power of n plus 5 minus n minus 1.
Oh my goodness. I committed the cardinal sin that you have to watch out for is when this goes to the top, it becomes minus n minus 1. So just to focus, to show you that it can even catch teachers, when you go this n plus 1, when it goes to the top, it needs to become minus n minus 1. And if that works out, let's reverse for a second. We get n, so n plus 5 minus n minus 1. And so we get n plus 5 minus n minus 1, which then gives us 5 to the power of 4. And then this is 1, this is 8, and this is just going to be 250, which then gives us 10,000. Super impressed. I'm really, really stoked that you guys picked it up because it shows real understanding.